far, we have worked with lists, tuples, which were both ordered sequences. Today, we shift gears and look at something unordered, mutable, and unique. That's nothing but the Python set. So sets are great when you don't want duplicates in it. You want to perform math-like operations such as union, intersection, etc., where the order doesn't matter. Now let's dive in. What is a set? A set is an unordered, mutable, and unindexed collection of unique elements. Now think of it like a real world set of items. No duplicates, and you don't care about the order at all. That's where sets come in. So what is the syntax for a set? I'm going to create a variable. My set is equal to 1, 2, and 3. Right, so this is the syntax. Right, so I'm going to give a curly bracket within which I'm going to put the elements within it. Right, so if at all I have to create an empty set, right, so I'll have to use this term set. Right, so empty set is the variable name. I'm going to create an empty set. I'll give an open close bracket. This is a function, right? So this is a method. So I'm going to give set open close bracket. Right? This is the right way of doing it. I should not create it something like this, right? So this empty set, not an empty set, right? So I'll put not a empty set is equal to open close parenthesis, right? So this doesn't become an empty set. Rather, if at all I have to create an empty set, I'll always should use the set name and have an open close parenthesis within it, right? So if I'm going to put in values within it, I'm going to use a curly bracket. Now let's create a set. Colors is equal to red, green, and blue. Red, green, and blue. Right? So what are the colors? So and let's also create some numbers. 1, 2, 3, 3, and 2. Now let's print the numbers here. Right? So when I've printed the numbers, you can see automatically only 1, 2, and 3 is displayed. However, 3 and 2 is not displayed again. Can you pause and guess for a moment what is the reason here? Yes, you are right. Right? The sets does not have duplicates. Sets is not ordered. Right? So let's go back here. Here we have sets are unordered, mutable, and unindexed unique elements. Right? So in other words, let's give it not ordered. It's unordered, mutable. That means what is mutability? I can change the values that's present here. So I can add or delete an element that's present within it. This does not allow duplicates. And fourth important point, this is not indexed. This is not indexed. So these are the 4 important points that we should remember. These are unordered, mutable, does not allow duplicates, and these are not indexed. Right? So this is very important takeaway here. How to access elements? How to access elements in sets? Right? So I'm going to give print colors of 0. Right? So you can see the set is not subscribable. That means, right? So the values, it does not have indexes. Right? So I cannot use an index. Right? So if at all I'm going to use an index, it will throw me an error because these are unordered. Right? These are randomly placed. Right? So however, I can loop here for in colors. Right? So I can print the color, print there. So whatever the values that's present within the set, I can iterate it. However, I cannot call it with index values. Now I want to add elements here. Add elements. How will I add an element? So in this colors, I'm going to add yellow. Now let's print colors. Right? So you can see blue, yellow, green, and red. So yellow is present within this variable, within the set colors. Right? Now I want to remove elements. Right? So how will I remove an element here? So colors dot remove. Right? So let's say I want to remove green. Right? So I'm giving green here. Right? So and now let's print colors. Right? So now the green color is removed. Now let's give this colors that remove again. Right? Now it's going to throw an key error, green. Now when you are doing this, in a programmatic manner, sometimes, right? So if some elements is not present, I don't want to throw an error. This could stop the iteration, or this could stop the flow of an application. Rather, so in that scenario, I could use, there is another function here, dot discard. Now let's discard a different color, yellow. Now let's print colors. So the yellow color is not present within the set. Now let's take this run again here, right? So even though the yellow color is not present, this will not throw in key error, right? This will not throw in key error. So no error even if the element is not present. So these are some useful functions when I don't want to stop the flow of an application, right? Some program that I built, right? So either you can put and try exceptions. Exceptional handling can be done, but still by default for this they have given this dot discard method, right? Now I want to delete this set completely. Colors dot clear, right? So now let's print colors, right? So it's only the empty set, right? So all the elements that's present within the set are deleted or removed, right? So that's what clear function that's present in this set, right? Now the set operations, the famous set operations that we often tend to perform. The set operations how we do in our math, right? So A is equal to 1, 2, 3. B is equal to 3, 4, 5. Now let's print A or B. A or B. So what does it mean? 1, 2, 3. So 3 is present twice. So since the sets remove the duplicates, it's going to remove the duplicates and print only once, and all the elements that's present in this variables A and B are printed. In other words, these are nothing but print A dot union B. 1, 2, 3, 4, 5. So the union is what is performing. Now let's see intersection. What is this intersection? Now print A and B, right? So A and B, whatever the element that's present in the variable A and B, that alone is printed here. Now let's print A dot intersection B, right? So it's similar to a union, right? So union is going to, it's like an OR gate. All the elements are shown here. It's like an AND gate. So whatever is common between these two sets, only that is shown here. The intersection, like the set operations that we used to perform in our mathematics, right? Now let's see. Now let's print A minus B, right? So what is A minus B, right? So whatever the elements that's present in A and that should not be present in B, right? So A minus B, only 1 and 2. That's the difference here, right? So in similar fashion, print B minus A. Now pause for a moment. Think what would come here, right? So as you have guessed it right, 4, 5, right? So 4, 5 is coming up. Now let's print A cap B. So this is the symmetric difference, right? So whatever is common, that's left behind, and rest all elements are printed, right? So you call it as an symmetric difference between these variables A and B, right? So we can keep on speaking this, and so these are the common methods: add item, remove items, discard item, clear, union, intersection, difference, is subset, is superset. So these are the default methods that's present within this set, right? So now let's wind this up. I'm going to use and set only when you want unique items. When the orders doesn't matter, you need to do some map operations. You want fast membership checking, right? So in is faster in sets than the list, right? So in, right? So the in, whether an element is present within this, right? So I'm going to check that. Now let's see, now this is a challenge for you guys, like kind of an homework. Now I want you to create two sets, one with the students who are enrolled in Python, one with students who are enrolled in A. I want you to do the following. Find the students who are enrolled in both this Python batch and also this A. Again, who enrolled in only one course, right? So Python or in A. So who is enrolled in either, right? So this gives you a very good standing position for the importance of set and why do you need a set. Now in this session, you learn how sets help you handle collections of unique, unordered items. You have also explored powerful set operations that can simplify real-world problems like grouping users or comparing data sets. In next session, we'll start with dictionaries. So what is a dictionary? Right? So the dictionaries are the most flexible and powerful data structure in Python, where each item has the name and then value. Thank you.